My name is Tina Liu, and I'm here to do the homework 7, problem 7. And so for first one, we are asked to find the expected value of the ZT. And for this one, we can see the clue give us the starting initialization of this problem is expected value of ZT is equals to, I'm sorry, wait a second. It's expected value N1t multiplied by cosine omega ct plus theta and plus the n2t multiplied by sine omega ct plus theta. Okay, so the next step we need to do is to separate them we using the expect value basic rule, which is the using it like this. To divide every every item out of the formula to make it all included by a separate expected value. So it will be like this form. Right? So the next step is uh to translate them into the form we can calculate. And firstly, since we know that the N1t and N2t is the y-sense stationary, so we can directly write it into mu1 and multiply by the 1 over 2 pi and the integral of the 2 pi from 0 to 2 pi, the cosine omega ct plus theta vs theta integral. I think it's the cosine expected value form for this problem. And also for the next part, since we know that the n2t is also the y-sense stationary, so we can write it into mu2 and multiply it by the exactly same form of the integral from above cosine sine omega ct plus theta d theta. Okay, so this problem, we see that firstly we know that the range for the integral is 0 to 2 pi, which is a full round of the cosine or sine. So for cosine and sine, they are both the odd function. So we can just uh have one result for that, which is the obviously both integral is equals to 0, which means the final function of the expected value of the gt is equals to 0. So that's it for problem 1, problem A, part A. And then for the part B, I think we need to find the RZ T1T2 is and to find whether ZT is wide sense stationary. And for this one, we can see also see from the clue for the homework 7, the RZ T1 T2 is equals to expected value of the ZT1 ZT2. I think the next step showing on the homework clue is a little bit complicated, so I will just follow the clue to set the next step. We can see the first item is the exact value of the n1 t1 multiplied by cosine omega c t1 plus theta, and then multiplied by n1 t2 cosine omega c t2 plus theta. And we can translate it into r n1 and multiply by expect value of the cosine omega c t1 plus theta multiplied by cosine omega ct2 plus theta. And another one is to the sine. With both of sine, we can have the Rn2 multiplied by expect the value of the sine omega ct1 plus theta multiplied by sine omega ct2 plus theta. Yes, so we have done the part of the both sine or both cosine. And for the one sine, one cosine, we will have the mu1 and mu2 multiplied by cosine omega c t1 plus theta multiplied by sine omega c t1 t2, sorry, t2 plus theta. And also we have another sine cosine, which is the sine for t1 and the cosine for t2. So it will comes out like this. Oh wait, it's the sine first. Sine omega c t1 plus theta multiplied by cosine omega c t2 plus theta. I think that's it for the normal form of the problem. And since we have the expect value of the cosine sine, we can rewrite it into the answer of the expect value into the integral, and which comes out to be and that's one part of the Rn1, and we can also write out the Rn2. Plus 2 theta, d theta, and plus sine omega c. And uh, wait a second. I think I wrote it wrong. Oh yeah, I wrote it right. I wrote it right. No, I wrote it wrong. I think the part of that is the minus for the cosine omega c t1 t2, and you see the yes, using the minus of the cosine. Yeah, I think that's the answer of the R1 R2 part. And also we have to add the sine cosine part, which is the to do the sine omega c t1 plus t2 first plus 2 theta and d theta. That's the integral part. And we need to minus the sine omega c. And also we have to add one part of the sine cosine again. Plus t2 plus 2 theta d theta and plus sine omega c. And that's it for the all the to write out of the expect value part. And for next, we can regenerate it, and it comes out into the over 2 of the Rn1 plus Rn2 multiplied by cosine omega c sine omega c, and which equals to the Rz. And I think from the above, we can also conclude that the Rz of the T1, T2 is also, we can see the Zt, Z function of the T is also the y sense stationary. And for next, we can just follow the hint, the clue of the homework 7 and write out the part of this one. Since the cosine will not influence it, the cosine will become the 1. So we can just, we can write it out, cosine 0, which is equals to 1. So final will be 1/2 with the expect value of the n1 square t plus expect value of the n2 square t. Yeah, I think that's it for this problem. And thank you.